So that's a reminder of what convolution is, cyclic and non-cyclic, vectors and functions. Okay, then eigenvalues and eigenvectors are the next step, and then the convolution rule is the last step. So, eigenvectors. Eigenvectors of circular. Of course, I can only do square matrices, so I'm doing the periodic case. So the eigenvectors are the columns of the eigenvector matrix, and I'm going to call it F for Fourier. So F is the first eigenvector is all ones. The next eigenvector is the fourth root of 1, then the square root of 1, I6, I8, I fourth, I6, and finally 1, I cubed, I6, I9. Okay, that's F. Those are the 4 eigenvectors of the permutation P and of any polynomial in P. So my circulant is some C naught I plus C1P plus C2P squared and C3P cubed. Okay. And finally, this is like the step we've been almost ready to do but didn't quite do. What are the eigenvectors? What eigenvectors are its eigenvectors? So those are the eigenvectors of P. And now we have just a combination of P's. So I think the eigenvectors, I just multiply, I take that same combination of the eigenvectors. Yeah. Does that look right? So, sorry. I'm sorry. It's eigenvectors. They're the columns of F. The question I meant to ask is, what are its eigenvalues? That's the key question. What are the eigenvalues? And I think that if I just multiply F times C, I get the eigenvalues of the matrix C. That's the beauty. That's the nice formula. If my matrix is just P alone, then this is 0, 1, 0, 0, and I get 1 I squared, I cubed. But if C is some other combination of the P's, then I take the same combination of the eigenvectors to see. Yeah. Do you see it? So I'm claiming that I'll get the 4 eigenvalues of C from this multiplication. So, of course, if C naught, if there's only C naught, then I only get C naught, C naught, C naught, C naught. It's a repeat, 4 times repeated. But if it's this combination, then that matrix multiplication takes the same combination of, this is a combination of the eigenvectors, and that gives us the right thing. Okay. So that's, now I just have one more step for this convolution rule, and then I'm happy. Really, the convolution rule is stating it's stating a relation between multiplication, which we saw here, and convolution, which we saw for the coefficients. So the convolution rule is a connection between multiplying and convolution. And so let me say what that convolution rule is, and let me write it correctly. So here I take a cyclic convolution I'm dealing with square matrices. Everything is cyclic here. And then I get, if I multiply by f, what do I have now? What does that represent? This was C and D, and I convolved them. So I got another circulant matrix. So up here, the multiplication of matrices is C times D. I want to connect multiplying those matrices with convolving the C's. I want to make that connection. Right. So, and that connection is the convolution rule. Okay. So this would be the eigenvalues of CD. Let's just pause.